Hello, today I'd like to go over Chapter 9, Transaction Isolation Level. Uh, there are four types of transactions: read committed, which has no lock and it will lead to dirty data. Read committed. This is the SQL Server default setting. It reads only the committed changes. Repeatable read has a lock on the update. So other transaction will wait if they're about to make updates. Serializable is update and insert lock. MS snapshots, this is the new features added, but this is too expensive to delete and update. So that means it's not useful but certain cases it can be used. Transaction deadlocks is waiting for other transactions to commit. There might be multiple transactions happening and it's waiting for the other transaction to commit changes. But it will not happen because both connections are waiting for the other to make changes, but it will never happen. So that leads to deadlocks. I'm going to demonstrate a few things here. So transaction examples, you can see the um, briefly orders and detail tables executing this. So you see the records there. Now I'm about to make changes here, start transaction, um, and it's going to add the records and it's going to show the scope identity. Scope identity is coming from here. Let me, it's coming from the table, orders table, which has the order ID, but the data format is the identity. So it will lead to whenever some records are added, it will scope identity, as you can see in pink, is a reserved word. So what happens is that it gets the latest um, ID number, order ID number, because the column data type is identity. So it picks the identity value and saves into the variable called new order ID. Once the value is saved, you can see the select the variable number and as the column name. So it will display the value there. Now once that happens, the new order ID is inserted into the orders details table. You can see the order ID and the value is coming from the here to this and here to this. Then you can see new order ID coming from this is supposed to have a value. It pulls the identity value, but in this orders table, the column order ID does not have the identity set on, so that will lead to value to be a null. So if you say after inserting a record, you select the value into this, you're supposed to see null value because there's no identity. The column order ID is not identity value in the orders details table. So that's why it shows the null value. So I'm going to run this one here. See this value here, 11,088. That's coming from the orders table. This is order table. After adding one records into this, the identity value is coming from here. So you can see on the value. Copy this. You can click new query. It will generate new sessions, and so you can see the value there. What is the value? So you see the 11,088 in the orders table. So that's the value you get here because the column is the identity. On this one, second one here is coming from the orders detail, but it has the value called 11,088. But this column, when you look at the table, it does not have identity. That's why it comes with a null value there. Locking and blocking there. It can be used your current connection. I'm gonna connect to locking and blocking issues on here by having one connection. Highlight this, copy down to the where it says the connection to. So I'm gonna make this. Make sure you clean all the connections here. Close all but this connection. That will say no. That means that you have only one transaction here. The session is alive. So after you copy this, and click New Query. And this is the first section, connection 1. So I'm going to run this one here, and it committed. Update is committed. Begin transaction. This is this setting the transaction, starting any batch updates will start with the begin transaction. So next one is opening the connection 2. Copy this, and this is the running just select statement there. New query, copy, and run this. 57, 56, update this to be this. So added, one record's added, and 57 already. So now, if I go back to this connection 3, so I'm going to type this connection 3. So I'm going to open new connection by clicking new query, copy this. Make sure you have session 1. So this is 57. You have two connections. So currently I have two connections. One is 57, and the other one is the 56 and 57. Sessions ID coming from here. So when you run this, make sure you change that value, this one, to find and replace. Oops. So replace, copy, 57, replace all. The session ID changes all the time, so you cannot have a static value, because if I open another session here by clicking new query, it will create new sections, session ID, serves process ID there. So by having, once you find this, just replace that and run this. Then it will show you all these uh, current session here, the value, and what queries is running here, and whether who's logged in, and you can see the host name and program name. Also the select statement there, it has a blocking session is the 56, so there's a transaction about to happen, but it reads it without any lock. So this is what you call dirty transaction reading. Close this session. Now, if you go back, now it's done with this. Now, session connection 2. So this is connection 2, source 2. Now, if I add this line, it says it's still executing here because when you read it, see on here, query executing query, it keeps running and you can see the 4 minutes passed. Still, on top here, it cannot read the value here because the default setting is read committed. So it's waiting for the other transaction to commit this one. Once this is committed, then this will be completed. So you can see the 4 minutes and 26 pass and still running. So this is what you call so go back to session 2. If I change this one to be I'm going to kill this one here because it keeps running it. Or you can say on the transaction 1, you can say commit. So this one here, 56. Go back to the first session here. You can say commit transaction. Then it will stop pausing this one here. Oops. 5 minutes just passed. So this one, 56. This one here. So I can say, as soon as I say commit and running it, the 4 minutes 5, the query, this will be completed. So I say a commit, say command committed. So session 1 is committed. Connection 1 is committed. Now go back to connection 2. After 4 minutes and 45 seconds, this reading is done. So that's why the transaction is important. It seems like it's not working, but because of the other connection is about to make a transactions, it was waiting for that to happen. So in this case, I can do one more case with the option of set lock timeout. So by using this one here, I'm going to run the same thing here with the transaction without committing it. Running this, and it says 56. The transaction is not committed. If I go back to this connection 2, and with the option of set lock timeout with the 5,000, that means the 5 seconds. Let's see what happens here. Option, running it. There you go. So lock request timeout period exceeded. So it's going to wait for 5 seconds and the other one transaction is not committed, then it gives you error message. Why is it better? There are times the new session can connect to the database, this one here. But if this one is hanging for 5-10 minutes, that means it will lead to a serious problem in the database level. So it's sometimes you set lock timeout 5 seconds, and if it doesn't return any value from the request, then it just terminates connection. This is the SQL application. Any web application will have this kind of settings, set lock timeout. So this usually set in the IIS, Internet Information Server, or Java servers application will have this kind of setting, lock timeout. So instead of waiting for forever. Now let's look at the read uncommitted. The previous one was read committed. Now if we do read uncommitted, so I'm going to kill all the connections by using close all but this. So I have only one. So I'm going to do read uncommitted. will read even the uncommitted updates from the other connections. The last time it was waiting for it, this time uncommitted, the option here will read updates, even the transaction is not committed. Copy this, new query, paste, run. So it's making the updates here. Going back to this, connection to. So set transaction isolation level read uncommitted. You can manually override the default SQL Server transaction level, which is the read committed. Now it's changed to read uncommitted. And this, copy, new query, paste, run this. It returns the value right away, less than 1 second. It returns it. The last time it was waiting for 5 minutes, still waiting for it until the transaction to be committed. This time it returns right away. Is it good? Well, it shows 21, and because it's coming from the value, it just add $1 into this and returns the value. It says 21. But what if the transaction is not committed? For example, here it comes down to be connection to be 1. Going back and rollback transaction. So if I do rollback transaction here in this one here, that means the actual value will be $2 instead of $21. Sometimes they make it here. So if I run this query statement here, actual value is $20, but the other session it shows $21. So this is a dirty data. It's not actual committed transaction. This cannot be used for any database level. That's why this is not recommended setting, but it returns the value quickly. Definitely banks will not use this kind of setting because sometimes a customer goes into the bank and withdraws money, then they change their mind and saying, "Oh, I don't want this cash back. Can I put the money back?" Those things. So the transaction level, it guarantees the something to be committed. Otherwise, the other section will not be able to read. But by overriding read uncommitted option here, it's going to read the dirty data, which is not saved into the database yet. So going on to the read commit isolation level, this is one we did last time here. Now, if we go back to going to the repeatable read isolation level, repeatable read, this is the make other, so read level, repeatable read, make other connections with update. Insert is okay. If the other connection is making updates, it's gonna make the current connection with this select statement will cause the other updates to hold. So on this one here, I'm going to do copy connection 1. I'm simply reading it, close all. So I'm making new connection by using query and this. I'm setting the repeatable read, and I'm reading the records because I'm about to do some kind of change here. So when the repeatable read option is done, that means its whole table, this one here, products table will have a lock. So the other transaction will not be able to make any changes while this is doing something. So on here, running this, and going to the second session here, connection 2, and about to make updates. Paste, run. So it's going to hold forever, 3 seconds. After 5 minutes, 10 minutes, 20 minutes, 1 hour, 5 hours. It will keep waiting it until this completes the transaction. So copy this one here, going back to connection 1 and say commit transaction, and going back to this, what happens? It commits automatically on here to connection 2 is committed. So it was after 33 seconds. So updating happened only one records, but it took 33 seconds. It's not database level because the uh, others connection is about to make a transaction. That's why it was holding that lock. Close all connection. Now, next one is the serializable isolation level. Serialized isolation level is the most expensive. It has a lock on the updates as well as inserts to wait. So the last time this was the update. Now, once it tries to make a connection, copy this, set transaction isolation level serializable, running this, and it's 12 records there. And it's gonna have insert, open new session, paste, insert. It's gonna hold forever until this one is committed, the session. Connection 1, going down, and until the first, this one here does the commit transaction. Let's wait here. Let's see. It's still waiting after 34 seconds. Still, it cannot insert any records because of this session. This connection is about to make some change. So when it commits the transaction here, done. Now, if we go back, it says one row affected. So that means that how many records do I have on here? So this second session was waiting for this first session to commit. So once it commits it, then second session will add the records. So now if I do select this statement here, I see 12 records there. How many records do I see if I run this? Oh, this one here, because it's repeating it here. So I'm going to run this category, running this. Well, could not find the store procedure connection. So let's say commit. No commit there. So 1 executing. So 13 records it shows up here. So it's not reading the dirty data. It's waiting for sequential to happen. Once this session connection is committed, then this will perform. And when it goes back to here and look at the records, then it shows the one row added from this connection too. Clean up. There we go. Close all. Now let's look at the deadlocks. Both connections cannot commit the changes because waiting for other uh, connections to finish committing. So now let's look at how deadlock happens. Going on here, session new query, copy, execute, one row. Now going back to the connection it's gonna do updates, new query, and it's gonna say up begin transaction, running this, 44 rows affected. Now it looks like seems like everything's done. One row is updated. This one is the 44 records updated here. Now it seems normal up to this point here, but if you go back and see commit the transaction, copy this, and going back to first transaction here, first connection. Now it updated one rows here and it's about to commit the changing into the database. Now what happens here? Execute this and it's gonna hold it. It's gonna wait for this connection 2 to commit the change. So this one is already made one record change and it's about to make a change into the database. Now, if I do copy this connection to this connection to, and I'm trying to commit the change, same thing here, and it still holds, it's going to wait, and wait, 19. Oh, why does it happen? Well, this one has the transaction deadlocks, so it's supposed to wait forever, but the database, there's a default setting. If there's a deadlock happening and wait for a certain time and it kills the session ID, process ID is 56. So deadlock can be released if both connections are waiting for each other and if it exists like 40 seconds or if there's a server setting on here that deadlock setting, you can override the default setting. But it's good to have there's times you will have deadlocks and you will see an error message saying deadlock on the lock resource with another process has been chosen as the deadlock victim. Rerun the transaction. So it rolls back the transaction automatically. It cannot commit the transaction. So if you run this, nothing was committed to the database because both this and this were waiting for that to happen. So that's what happens here. So it terminates it, and this one has to be committed. It has to run. The application has to run this up, the update statement again, because there's an error happening. So occasionally you will see these messages because both sessions are waiting for a resource to the other to commit. So this is what happens.